Okay class, welcome back. Today we are going to talk about determining how far a reaction will go. Today we will introduce limiting and excess reactants. My objective for you today is that you'd be able to calculate and determine the limiting reactant and how much product will be formed given that amount of reactant. And saying that, let's dive into what we have today. Rarely are both chemical reactants entirely used up within a chemical reaction. Generally, one reactant will be used up while the other one is left over and not fully consumed. The reactant that is fully consumed is the limiting reactant. Just like a fuel for a car, the limiting reactant is the main determiner on how far the reaction will go. Once the limiting reactant is used up, the reaction can go no further or no longer proceed forward. No matter what environmental changes you may introduce to the chemical system, once the fuel source is used up, there's nothing more you can do to get anything from this reaction. What reactant is left over after the limiting reactant used up is called the excess reactant. As the name implies, the excess reactant is the reactant that is in excess or is left over after the reaction has occurred. So to illustrate this, let's look at it this way. I have 5 screwdrivers, 3 pliers, and 6 hammers. I need to make groups containing one of each of these 3 tools. So let's start off by making our first group, one of each tool. That leaves me 4 screwdrivers, 2 pliers, and 5 hammers. I could continue to make 2 more groups, leaving me with 2 screwdrivers and 3 hammers left over. Since I do not have any more pliers, I cannot make another group of tools. Because of this, my pliers are my limiting reactant and are fully used up. My screwdrivers and hammers are left over and cannot create a group with 3 different tools. Because of this, they are our excess reactants. Okay, so now that we have seen how to calculate a simplified version of limiting and excess reactant, let's actually see the steps in order to determine the actual limiting and excess reactant within a chemistry problem. Let's say we're given the following problem. Say a reaction between 25 grams of white phosphorus, which is P4, and 50 grams of oxygen produces solid tetraphosphorus decaoxide, or P4H10. This is often called diphosphorus pentoxide when it's in its empirical formula. Determine the limiting and excess reactant for this problem. First thing we're going to need to do to solve this is write the chemical equation that is occurring. So if I write this equation and balance it, we should have the following reaction or following equation. P4 plus 5O2 yields P4O10. Next, I am going to solve a mass mole problem for both the reactants to see how much product is produced for each reactant. So, let's solve for my white phosphorus first. So we're given 25 grams of P4 over 1. We convert that to moles of P4 by multiplying it by 1 mole of phosphorus over 123.9 grams of P4. That gives me 0.202 moles of P4. Now I can convert that to moles of P4O10 by using the mole ratio, which just happens to be 1 mole of tetraphosphorus decaoxide over 1 mole of white phosphorus, or P4, which still gives me 0.202 moles of tetraphosphorus decaoxide. Okay, so now we got that one. Let's do the same thing for our oxygen. So we put 50 grams of oxygen over 1, and we want to convert that to moles, or multiply it by 1 mole of O2 over the formula mass of O2, which is 32 because O2 is diatomic. Okay, this gives me 1.56 moles of oxygen. Now all I have to do is multiply it by my mole ratio of tetraphosphorus decaoxide over moles of O2. So 1 mole of tetraphosphorus decaoxide over 5 moles of O2. This should give me that my 50 grams of oxygen can produce 0.312 moles of tetraphosphorus decaoxide. Now I'll compare my moles of product produced and see which one is smaller. The smaller one is the limiting reactant, while the larger one is my excess reactant. In this case, the white phosphorus produced less P4O10 than my oxygen, so my white phosphorus is my limiting reactant, my oxygen is my excess reactant. If I'm asked how much excess I have left over, all I need to do is subtract the number of moles of limiting reactant from the moles of excess reactant, so that would be 0.312 minus 0.202, which would give me something like 0.11 moles of my product left over. From there, all you have to do is use the mole ratio to get moles of reactant. And if they're asking for moles of reactant left over, then you're done. But if you are needing to convert all the way back to grams, then you're going to have to use the formula mass again to get to grams of that. So you're just basically working this backwards. Okay, that's enough torture today. Limiting and excess reactants use a lot of math and can be a pain to work. Once you get them down though, they're not really too bad. Remember, you can always rewind and rewatch parts of this video if you need to. Keep up the good work in class, and see you next time.